Hi YouTube, this is Stefan from Be a Python Dev. Today I'm briefly going to talk about variables. So variables are very important to programming. They allow you to store your values and carry them between different methods, and you can input your data into the variables. So when you declare a variable, it saves space in memory for you to store this data that you're representing. Integers get stored based on how large the integer is. So a 32-bit integer that gets stored in 32 bits of memory. So when you declare a int 32, your program will automatically allocate 32 bits of memory within your program memory space for you to store that value in. That goes based on binary, so a 32-bit value would have 32 ones and zeros. 1, 2, 3, 4, 8, 12, 16, 32. So this is how a 32-bit value would get stored into memory. This, of course, corresponds to 0. This corresponds to 1, corresponds to 2, and so on. So I can't remember off the top of my head how large of a number can you store with 32 bits. All right, how many numbers can 32 bits hold? So in programming, there's also signed and unsigned. That means that you have a 1 here, this would be a negative value, and if you have a 0 here, this would be a positive value. Your computer will look at that first bit to decide how it should handle this number. So unsigned, you can store numbers as large as 4 million, and then unsigned would be half of that, but then you would get the full range from 2.1 to negative 2.1, etc., etc., etc. Feel free to just Google this, read through this computer memory wiki and 32-bit wiki if you want a little more detailed. I don't want to get too technical in that. And also variables can also store strings. So we'll do my string equals hi. So how the Python interpreter handles this is it actually declares a list or an array. I'm not exactly sure. And then it stores this as a character array. At least I know that's how Java and C does it. I'm pretty sure Python's the same thing. So behind the scenes, Python probably creates array. Well, let's just say jar array equals h, and then I. That's not an I. And then this is how this would get stored in memory. And then it would use the Ascii conversions. So the computer program takes your letters, converts them to ASCII representations, and then puts those in memory. So this character array will automatically create an array of characters, and then the computer knows that a character is only 8 bits wide. So if you have a character array of 2 letters, the computer program will make 16 bits of memory and throw those values in there for you. So I want to say, let's see, capital H, capital H. This is the right ASCII table. All right, so in our example, my string equals hi. Character array would be hi. The computer program would think of these as numbers. So h equals, based on the ASCII table conversion, it would be a 72 value. This is the base 8 representation, this is the base 16 representation. So h equals 72. And then I equals, lowercase I, equals 105. So if you have a character array of capital H, lowercase I, it's basically the same as having a decimal array of 72, 105. Because the computer does not know what letters are. The computer also doesn't know what 72 and 105 is. It only stored values of high and low based on your memory space and your hard drive little bumps and pivots. You can learn a little bit more about that in computer architecture. If you have already taken it, then this is all just kind of review. All right, so the H would get stored in a hex of 48. Hex can also be converted directly into a series of 4 bits. So 72, actually just make a comment. So H equals hex 0 by 42. So this was just supposed to be talking about variables, but I guess we ended up turning this into a how does computers store data discussion. Also for my own review. And then lowercase I, 0 by 69. So this gets converted to memory in this way. 0. That is a 4. Actually, it's a hex string of, yes, and F is, no, F is 1111. That's right. So an 8 that way. So 8 bits wide. First one is 4, second one is 8, which converts to 72, which is represented as a capital H. So 69 would be 0, 1, 1, 0. Then 9 is 1, 0, 0, 1. So this is how the computer stores high. So the computer will look up the memory index when it refers to our myString variable later on in the program. It will pull in these values. The computer program will interpret these values and see that this is supposed to be a character array. Based on that, it will be able to dechunk these into bits of 8. It will see that this is a 4/8 hex value, which corresponds to a 72, which gets mapped to a capital H. And then same for this one, hex 69, decimal 105, gets mapped to a lowercase I. So when the computer goes through this character array, and then we say print myString, later on in the program, we'll just run this, get rid of this, because that was a old value. Run Python file in terminal, and then it prints out hi. So myString equals hi, character array, capital HI, decimal representation 72, 105, hex representation 0 by 48, 0 by 69. This is how it gets stored in memory if we were to look at a memory dump somewhere. And then it gets reinterpreted for memory every time we reference the string later on in our program, well, the myString variable, and then it gets printed as hi. So I know that's a little convoluted, but definitely good to know about in the world of computer science.